in case anybody wants to watch it again later or if you missed it. All right, so the homework or the work from Friday was this set operations, and it's important, letting people in, sorry about that, so it's a lot of symbols. You may want to make sure that you know the difference between an intersection and what a union is. Two equal sets. Equal sets are sets that contain exactly the same elements. So the two equal ones looks like B 33, 36, 37, 38, 39, 33, 36, 37, 38. B and D are equal. They have the exact same elements as each other. Equivalent sets are just sets that have the same number of elements. So you have 1, 2, 3, 4 elements in A, 4 elements in E. So A and E are equivalent sets. They'd be the same size. So they'd have all the same number of subsets and stuff like that. Are there any other? Well, of course, B and D, but B and D are equal, but they would also be equivalent. That comma shouldn't be there, typo. All right. So what is intersection? Intersection is what they share, right? What they have in common. Where does A intersect D? A and D both have 36 and 37. So use set notation, the squiggly brackets, braces, 36, 37. Intersection, what do they both have? F and E, what do F and E both have? Looks like they both have 30. They both have 34, and that's it. Of course, the intersection could never be bigger than the smaller of the two sets. And it doesn't matter if I do E intersect F, F intersect, either way, you're doing the same thing. C and E, not 31, 32, 33, 35, 36, 30. C and E, anything they have in common, 33, 35. I don't see anything, so you would say the empty set, which is just a set notation with nothing in it, or you could use the null set, which is also the same. Those are exactly the same thing.
Mr. Rakowitz,
Yes. Did I miss that one?
can you explain number 2?
Yeah, equivalent. All equivalent means is that the two sets have the same number of elements. There are 1, 2, 3, 4 elements, and B has 4 elements. So that's all it takes to be equivalent. Equal, they have to be exactly the same. They don't have to have anything in common at all. They just have to have the same number of elements. So you could say that B and D are also equivalent because they do have the same number, but it's better to describe them as equal. All right?
Okay, thank you.
Equivalent is just the same number of elements. All right, so if you're going to intersect 3 sets, then they have to all 3 have something in common. So my brackets are horrible, I know. B, C, and D all have 33. Do they all have 36? Yes. B, C, and D all have 36. Do they all have 37? No. The C doesn't have a 37. So it doesn't matter that 2 of them do, they all have to have it. Do they all have 38? Nope. Do they all have 39? Yes. So when I look at intersections, it's best to pick the smallest set. You could have picked this one too. And there's no reason to go through all of these numbers. It can't be more than just these. So just check each one of those 5 numbers, make sure they're null. Union is combining the 2 sets together. Just don't write anything twice. So if you union E and F, then you would say they both have 30. So just write it once. There's a 32, if you keep them in order, not a 33. And you can look at your universal set to see what could be there. There's a 34 in both of them, but that doesn't matter, just write it once. There is not a 35, not a 36, there's a 37, and there's a 38. So it's just taking E and F and combining them together. Just don't write things twice in a set. If 30 is in the set, 30 is in the set, I don't need to write it twice. So C union E would be taking C and E. There's a 30 from E, 31 from C, 32 from C, 33 from C. There's a 34 in E, 35 in C, 36 in C, 37 and 38 are in E, and 39 in C. So when I union those 2 sets, they have 30, 31, 32, 33, 34, 35, 36, 37, 38, 39. They have all of the universe. So you could write this as just U for the universal set. So you didn't, if you're going to write all of them, you can just write universal set. All right, A union C, they have a 31. No, they have a 32, 33, 34. Neither of them have a 34. Both of them have 35, 36, 37. There's no 38 in those. There is a 39 in C. That doesn't have all of them, so that's subtraction. There's no negative in set theory. Subtraction is just all of the elements in B and take out any of them that are also in D. So 33 is in D, so it's gone. 36 is in B, 36 is in D, so you subtract it out. 37 would be subtracted out. 39, 38, 39. Actually, B minus D is all of them, right? Because they were equal sets, so that's the empty set. There's nothing left. Or the null set. Not a good example for the first subtraction, but we're going to have another subtraction. So when you are subtracting, if there is an element in what you're subtracting that doesn't exist in the first one, it doesn't matter. It doesn't affect anything. So like A minus D, there's a 31 in A. There's no 31 in D, so it stays. The 35 doesn't get subtracted out. The 36 does, and the 37 does. So that's all that would be left. But these, like this 33 that didn't exist in A at all, has no effect on that subtraction. So it's only taken out. When you do subtraction, you're either going to get set A back or some subset of A, something smaller than A, but never are you going to have numbers come in that you're being subtracted out, if that makes sense, or elements. Which 2 sets are complements of each other? And we figured that out when we did the union, but complements of each other are 2 sets that if we put them together would have, so if 2 sets, let's not use those letters, let's say set X and set Y, if they're complements, then they're going to have nothing in their intersection. And when you union them, you will get the universal set. That's what it takes to be a complement. So everything, and I think it was B and D. No, it was these two that we put together, C and E, because C has 30, and there's not a 30. I mean, E has 30, 31, 32, 33. They're not over here, 34, 35. So these two together, if there are 1, 2, 3, 4, 6, 7, 8, 9, 10, then complements would have to have 5 and 5 or 6 and 4. So this has 6 and 4, and these 4 have to be completely different than these 6, and together make everything. So it's C and E are the two complements of each other. This B with a hashtag is how you write complement. Some books use a C power for complement, but this is more common with the hashtag. But the complement of B would be everything that's not in B. So there's no 30 in B, no 31, no 32, 33 is there, 34 is not there, 35, 36 is there, 37, 38, 39. So that's it. Like I said, if B has 1, 2, 3, 4, 5 elements, then the complement has to have 5 elements because our universal set is 10 elements. And that depends on the universal set. So,
Wait, Mr. Rackwitz,
yes,
you said, so if it shows up like B1, that means that's just another way of saying what's the complement of B?
yes,
Okay.
yeah. That little notation, that little half of a quote sign, that is complement.
Yes.
Yep. All right, so now we have a bunch of fruit and different subsets of fruit. So H complement is going to be all the fruit that's not in H. So that would be the apple is not there. I think I used B, C, G, O, P. Yeah, I used fruits of all different letters so that you can just do the abbreviation. So H, there's no apple, there's a banana, there's a cherry, there's a grape, there's an orange, there's a peach, there's no raspberry, there's no strawberry. So here is when set operations, you need to start kind of taking it slowly. So if you have the complement of G union J first, right, what is G union J before we do the complement? So G and J, they both have apple. There's a cherry from G. There's a grape from J. There's an orange in both. And there's a raspberry. So when I union those, when I put them together, I get apple, cherry, grape, orange, raspberry. Now what's the complement of that is everything that's left out. So that's banana, grape, cherries in there, grape is in there, orange is in there, there's no peach in there, and there's no strawberry. So that's the final answer for that one. So take them one at a time, and it's just like order of operations. If there's parentheses, do what's inside the parentheses first. There's no parentheses, do what's the outside. So if I do the complement of G, G has apple, G needs banana, G has cherry, G doesn't have grape, G has orange, it doesn't have peach, raspberry, or strawberry. That's a complement of G. If I intersect that with a complement of J, which apple is there, so banana's not, cherry's not, grape is, orange is, peach, raspberry, strawberry. And now I want the intersection. What do these two complements have together in common, right? So that's B, banana. They don't both have grape, they both have peach, raspberry, strawberry. K minus H is just everything in K, subtract out anything that's in H. So banana would get gone, grape would get gone, orange is gone, peach is gone. All that's left is raspberry and strawberry. Why do I keep on making that S weird? So used to making those brackets. Yeah. So remember, it won't be bigger than 6, but it can be less than 6, and all of those got taken out. All right, so H intersect K and then the complement. So first I'm going to intersect them and then do the complement. So H and K both have banana. They both have grape. They both have orange. And they both have peach. Right? Banana, grape, orange, peach. Now the complement of that, again, is everything that's in the universal set. This time 1, 2, 3, 4, 5, 6, 7, 8 items in the universal set. So the complement of 4 items has to be the other 4, which would be the apple, not the banana, the cherry, not the grape, not the orange, not the peach, the raspberry, and the strawberry. Complement of H union the complement of K. The complement of H, which has to be 4 items, would be the apple, not the banana, not the cherry, not the grape. Oh, H is 1, 2, 3, 4, 5 items. This will be 3 items. Sorry about that. So not the orange, not the raspberry and the strawberry. I'm going to union that with everything that's not in K, 1, 2, 3, 4, 5, 6. So there's only 2 things missing in K, which is the apple and the cherry. And now union is to put those 2 together. Just don't write anything twice. So the apple's there twice, just write it once. The cherry, the raspberry, the strawberry. All right. If you're going to union 3 things, you're just putting them all together. So in this case, I'm going to look and say, does any one, the G, the H, or the J, do any of those have an apple? So I'm going to look at the universal set and see, because the union, just one of them is enough to put it in the union. There's a banana from H. Does one of them have a cherry? Yeah, G has a cherry. Does one of them have a grape? Yes. Do any of them have an orange? Yes. Do any of them have a peach? Yes. Raspberry? Yes. And do any of those have a strawberry? No. So that's everything but the strawberry. The intersection is they all have to have. Do they all have an apple? No. Do they all have cherry? No. Do they all have banana? I skipped banana, but no. Grape? No. Do they all have orange? Yes. That was next, right? So there's an orange, there's an orange, there's an orange. They all have an orange. Peach? Nope. Raspberry? No. And of course, not strawberry, because none of them had the strawberry. So that's just a single element, just the orange. So K minus G union H is going to be K minus, and then union the G and the H would be the apple, the banana, the cherry, the grape, the orange, the peach, and the raspberry. That was it. Yep. So K, anything that's in K that's here is going to be taken out. So is the banana taken out? Yes. Is the grape taken out? Yes. The orange? Yes. The peach? Yes. The raspberry? Yes. The only thing that's in K that wasn't taken out is that strawberry. So parentheses first, so you're going to do G intersect H union J. And that's H and J together, which is the apple, the banana, the cherry, grape, orange, and peach. And then G, whatever's in this set, that's also in this set you're intersecting. So they both have apple, they both have cherry, they both have orange, and that's it. So that's the whole thing. So again, parentheses first. So what is J intersect K? What do these two both have? Apple, grape, and orange are the only two. Minus G, which if either the grape or the orange is in G, you'd take it out. And it doesn't matter that G has any of the others other than those two. It has the orange, so the only thing left is the grape. H intersect K is H and K both have banana. They both have not cherry, they both have grape. H and K both have orange, and they both have peach. And then I'm subtracting the complement of J. J complement is the five that aren't here. That's the banana, the cherry, the grape is there, the orange is there, the peach, raspberry, strawberry. And then just take, so the banana would be gone, the grape would still be there, the orange would still be there, and the peach would be gone. So it'd just be grape, orange. All right, so when you're just given a set, it doesn't matter what's in that set. You're just talking about any possible set, or it's a subset of this universal set, right? So if you put together, and I already did this one, when you have a subset with its complement, the union of the two, that would give you the universal set. That would be everything. Where if you intersect a subset with its complement, they have nothing in common. So that's the empty set, the null set. What's the complement of the universal set? Well, the universal set has everything, so the complement would have nothing. If you have everything and you take out A, you would be left with the complement of A. You'd be left with everything that's not in A. If you take A and you subtract the universal set, then everything that's in A is going to be subtracted out because it's in the universal set. So you'd get nothing. A intersect the universal set is because everything that's in A is here, all of that would be in the intersection. All of A would be in the intersection. Where if you put anything together with the universal set, you're going to get the universal set. Everything would be in the union. Just like subtracting the A from the universal set, if you subtract A's complement, you'd be left with just what's in A. If you intersect the universal set with any set, you get that set back. And if you union the universal set with any subset, you get the universal set. So that would just keep everything. Yeah. And I think that was it, wasn't it? Yep. All right. Stop that recording.